Hi everyone, this is CHM 304 and 403 Electrochemistry post-quiz workshop lecture for 2020-2021 session. I'm Andrew Tehemi. I lecture physical chemistry in the Department of Chemistry, Benue State University, Makurdi, Nigeria. This lecture is meant for my students here at the Benue State University as well as other students worldwide who are interested in the videos I produce on this channel. If you have any questions or any comments, you can send those to me using either my university email address or my Google email address. Alternatively, you can leave comments in the comment section of the video on YouTube and I'll do my best to respond. The quiz question says, for a platinum electrode in contact with an iron 3, iron 2 aqueous solution at 298 Kelvin, the Tafel plot of one of the processes is given in the graph. It further says, what is the scale of the plot? Is the process anodic or cathodic? What is the exchange current density for the process? Write the equation of the straight line of the plot. What is the value of the overpotential when the current density is negative 300 milliampere per centimeter squared? The Faraday's constant is 96,500 coulomb per mole, while the gas constant is 8.314 joule per mole per Kelvin. So for the first question, which has to do with the scale of the plot, if we examine this graph closely, we see that from here to there, which is 1 centimeter is skipped, and the next 1 centimeter has 1. That pattern is repeated. We've got 2 there, and we've got 3 there. So on the horizontal axis is 2 centimeters to 1 unit. On the vertical axis, we have from here to there a centimeter, and from there to there another centimeter. That is 2 centimeters to 50 millivolt on the vertical axis. So the scale is 2 centimeters to 1 unit on the Linge axis, the horizontal axis, and 2 centimeters to 50 millivolt on the overpotential axis, which is the vertical axis. The next question asks us to find out whether the process plotted here is anodic or cathodic. To do that, we find the gradient of the plot. To find the gradient, we draw a rectangle across the straight line. And if we look there, the points, there is negative 1.5 for the horizontal axis, and then negative 65 millivolt for the vertical axis. The same thing applies here. We've got 3.3 for the horizontal axis and negative 225 millivolt for the vertical axis. So the gradient is therefore change in the overpotential divided by change in lane J. So we substitute these values to find the gradient. And that gives this, which we can simply use our calculators to evaluate. And that gives negative 33.3 millivolt as the gradient. Now, because the gradient is negative, the process is cathodic. The next question says we should find the value of the exchange current density, which is J0. And the general equation of the line, which is this, is given by this because the process is cathodic. Now, what we need to do is to find the intercept on the horizontal axis. Now, on the horizontal axis, we have the intercept to be negative 3.4. And at this point, overpotential is equal to 0. So if we substitute 0 there for overpotential for the case of the intercept and rearrange this equation, we obtain this, which those common terms cancel out, leaving us with ln J naught equal to ln J. That is to say, the intercept on the horizontal axis is equal to ln J naught, and ln J naught is equal to negative 3.4. Now we multiply both sides by exponential, and that gives this. And exponential negative 3.4 gives 3.3 times 10 to the power of negative 2. We multiply both sides by milliampere per centimeter squared, and that gives J naught to be equal to 3.3 times 10 to the power of negative 2 milliampere per centimeter squared. The next question says we should find the equation of the straight line. And we know that the general equation of the straight line is as given for a cathodic process. And we know that the intercept on the horizontal axis is ln J naught equal to negative 3.4. The gradient is negative 33.3 millivolts, and this is equal to this because that is there. If you look at this in terms of the equation of general equation of a straight line. Therefore, if we substitute 33.3 millivolt for there, and negative 3.4 for ln J naught, then we are going to arrive at an expression that looks like this, which we use our calculators to evaluate to obtain the overall equation of the straight line, which is negative 33.3 millivolts times ln J minus 113.2 millivolts. The final question says we should find the value of the overpotential when the current density is negative 300 milliampere per centimeter squared. There are two ways we can do this. The first one, we find the natural logarithm of the absolute value of negative 300, and that gives 5.7. We trace the horizontal axis and locate 5.7, which is somewhere here. We draw a straight line from that point to the line of the plot, and then trace that to the vertical axis, and that gives negative 305 millivolt. The second way we can do this is to use the exact equation of the straight line. We substitute negative 300 here and evaluate the resultant expression. That gives this, which we can evaluate straight away using our calculators to negative 303 millivolt. You can see that the difference between the first process and the second one is just 2 millivolt, which is acceptable. Yeah, so if you find this video helpful, I invite you to subscribe to my YouTube channel, ring the bell so that when new videos are uploaded you'll be notified, like, comment and share. Thanks for watching. The link to the PDF version of this lecture can be found in the video description. If you have any comments or any questions, you can send those to me using either my university email address or my Google email address. Alternatively, you can leave those in the comment section of the video on YouTube, and I'll do my best to respond. Bye now.